Welcome back to the data structures module. So let's jump in with our random generator operator. So we've got this roll operator. So before we just discuss this in particular, I want to just mention we've obviously shown a lot of different operators that are one characters, whether it's the bang as the exclamation point, or casting was a $sign, for example. If that's becoming a bit overwhelming for you, there's a great summary on code.kx.com in this overloaded glyphs section, and what it does is it shows these really commonly overloaded characters. So for example, in the dollar, we can see one of the applications is cast, and this is how it would look, and you can see all the different examples we showed there. So this is a really good summary, one-stop shop. And if you maybe you're checking out someone else's code and you're seeing they have a lot of these operators, depending on the resulting notation around that, you should be able to figure out which one of these they're actually using. So I find this quite helpful myself. Again, here the bang one, we were using the key and the unkey one here. And now I've just started talking about question mark, which is here, and we're talking about roll. And this roll one is creating random data. So for example, if we have 3 roll, we go 1, 2, 3, 4, 5, 6, 7. You can see I'm getting 3 random numbers every time. Sometimes they're different, sometimes they have repeated values, like 1 and 1 is here. So yeah, that's how we can generate random data in Q, which can be very handy. And we can also do random access, and that's doing indexing. So again, using function notation here with the square brackets, we're looking for the 10th element, which is element 9, because indexing begins at 0. Your 10th element will be index equal to 9. And this is like the virtual I column. Same when I'm talking about indexing, I'm talking about the same thing. This is how we would index into lists. And if we wanted to get multiple indexes returned, we could just pass them as a list here. So this is giving me the first 10 to 10th element returned. We also have this till keyword, which is really useful. It will create a list starting from 0 up until the number you pass it. So for example here, I'm saying till 10, which returns 0 to 9, and then I'm passing that into fares, so my fares list. So that should return the same thing as above here. So for some reason that's taken a little bit of time to run. Let's just, run it again. So you can see here we get the same thing back. Till is super useful as well when you're generating data. If you didn't want to start at 0, for example, and you wanted 55 to 65, we could do plus till 10 here, or 64. So we got 55 to 64. So you can use this and adjust where it begins from by just adding on whatever number you want to your till keyword. So I've got a few exercises here, 15 and 16, to test your knowledge of that. So pause the video and have a go at those. And then we'll have a look at doing some indexing and what happens when the index used is too high. So for example, if I only have, I'm counting my list here. So let's do that at the beginning. So count, sorted, fares, and then let's pull this out as well, just so I can see what I'm doing. So this is the length of my list. And then I'm saying, okay, if I index in at the length of my list, I'm getting null returned. And then if I go 1 minus the length of the list, I'm getting the very last element of the list. So if we ran last on the list here, so last is, we've seen this before, we can use this to get the last element of the list. We see that's 200F, and if we did -2, that would get the second last element, and so on. So what we're basically showing here is, because indexing goes from 0 up to that number, if you did if we had +1 here, we'd also get 1 plus here, and we get null as well. So if you pass in an index that's too high, you're going to get a null return. So that's just illustrating that. And then we're saying we could have also used this to get the first value from the list, and just showing the difference between using sublist and first. So they both return the first element of the list, the difference being this prevailing comma, which means that that element is of type list. When you use first, it's just returning it as one element. So yeah, that's got a one item list. And if, say, for example, it was returned like this, but we wanted to convert it into a list and it only had one element, we could use the enlist operator, or we can also join an empty list to it using this. So this is empty list, comma, and the number I have. So you'll see both of these return a one item list. So a reason why you might want to do this, if you're inserting something to a table and the column is of type list, for example, and you just have one element, you would enlist it. So this as well comes about a lot when we look at functional SQL or functional querying, which is the next level up from QSQL. And that enlisting our different inputs into that comes into play a lot, which is again covered in a lot of detail in our more advanced courses. So now we've had a look at a few of the handy keywords related to lists. Let's have a look at list amendment. So say we want to change a value in our list. With QSQL, we know we'd use update. We've seen that. We could update our table that way. If we're using list, we have to use slightly different notation. One of the ways is using the at operator. Before we look at amending the list, we can also use this at operator to index into the list. So if we're not too sure which one we're using and what's happening, we can always go to our overloaded glyphs, click on the at here, and checking the notation, you should be able to find which one's happening. So in this one, I've got an at, I've got two parameters, the first one being a list, and then the second one being some integer value or long value, or a list. So this one here is a list. So this is saying index at these points. So this is doing the exact same thing that we've seen above, with just simply passing the indexes here. But we're just showing that you could also index this way. So this is returning the zeroth, second, fourth, sixth, and eighth element of that list. But we can extend this then and use this to apply a change. So that's down here, we're showing these amend at applications or replace at, and that's what's being shown here. So say, for example, instead of passing it one parameter, we're passing it three. So the first one, again, is our list. The second one is a list of indexes. Those are the indexes to be changed. This is saying what I'm doing. So I've got my colon, which I know is assignment. So we're going to overwrite these values, basically. And we're passing 99F. And that's the value that it'll be overwritten with. So if we run this, we see at the 0, 2nd, 4th, 6th, and 8th index. We've now replaced those values at 99F. If we change this colon to be plus, instead of replacing it with 99F, we'd be adding on 99F. So in this way, we can make changes to our list. In QSQL, we've seen that might be done with an update instead. So this is just how you would do that with lists. Just to note, sample fares, if you go and call it on its own, it's gone back to the original form. So we obviously need to put sample fares in front here if we wanted to persist that change. And also a second way of doing that to persist the change would be to change this to a backtick. So this is showing something very similar again. I'm replacing every second element with a null float. This is what a null float looks like. If you see something like this, you're not sure what it is, go back to your reference card and your data types, and over here you'll see all the null notation. So 0NF, I know it's a null float. And if I run this, I ran test here, test is updated, and now fares, what's returned from this is a backtick fares, and that's how you know your list has been updated. And then you can see this is persisted. If we had taken this away and checked it afterwards again here, it would not have persisted. So depending on what you're trying to do, that can be useful. Again, we can also use the join operator on lists. This is just showing that we can join elements to a pre-existing list, and we can precede the colon, the assignment operator, with the comma. This is the exact same thing as doing fares, fares, comma, fares, join 1, 2, 3, 4. Which is just saving us having to type fares twice by putting the comma in front. So we can do that. Some other handy keywords just to finish up on. We've got the word any and we've got the word null. So what null will return is a true or false if any nulls exist. So we can see at the 0, 2nd, 4th, 6th, where we've changed those to be nulls, they are now null. And that can be handy because we can see if you're looking for a certain result in a list, null can be quite useful. It will return booleans. We can also use the keyword any there, which will return true. So you're saying, are any of these null? And you can also say, are all of these null? So maybe you want to check, you know, are all of these a certain value or are any of them a certain value? And you get a boolean result returned here, which can be useful. As well as using any or all, we could also put the where in front. And that would actually, instead of returning booleans, it would return the indexes themselves where that's happening. So that can as well be very, very useful depending on what you're trying to do. So how about we go at exercise 19, doing some amendment using the apply operator, and I'll see you in the next video.